The most powerful machine humans have ever built looks like a grain silo. 16 million pounds of thrust, 33 engines screaming at once. A tower that catches rockets mid-air. And by the end of this video, you'll understand why this steel giant makes every rocket before it, including the legendary Saturn V, look like a bottle rocket. For half a century, one rocket held the crown, Saturn V. The machine that carried 12 humans to the moon and brought them all home alive. Standing 36 stories tall, powered by 5 F1 engines, each one generating more thrust than 3 modern jetliners combined. 7.6 million pounds of force at liftoff. Enough to shake buildings 16 kilometers away. Enough to make grown engineers cry. The F1 engine's turbopump alone produced 55,000 horsepower. Just the pump. That's more power than a locomotive to feed fuel into a bigger machine. Saturn V didn't just go to the moon. It carved a line in history. Everything before it was a toy. Everything after it, for 50 years, was smaller. When NASA retired Saturn V in 1973, the plan was simple: build something better. The next chapter, the evolution. Instead, they built the space shuttle. Brilliant in concept, devastating in compromise. Reusable orbiter, yes, but the rockets, disposable. Every launch, billions of dollars dropped into the ocean. Then came SLS, the Space Launch System. NASA's answer to "we need a big rocket again." And just now, literally a few days ago, SLS carried 4 astronauts around the moon on Artemis II. But here's the thing nobody's saying out loud. SLS produces 8.8 million pounds of thrust. Impressive, but each launch costs over $2 billion. And the rocket, thrown away. Every single time. So for 50 years, the throne of most powerful rocket ever built belonged to Saturn V. No one could touch it. No one could afford to try. But then something happened in South Texas. When SpaceX first revealed Starship, the aerospace world laughed. Not politely. They laughed like someone had walked into a Ferrari dealership wearing pajamas. Because Starship is built from stainless steel, not carbon fiber, not titanium, not aerospace-grade exotic alloys. Stainless, steel, the stuff your kitchen sink is made from. $3 per kilogram compared to over $100 for carbon fiber. Elon Musk didn't choose steel because it was glamorous. He chose it because it was genius. At room temperature, stainless steel is decent, but cool it to cryogenic temperatures, the kind you need for liquid methane and liquid oxygen, and it gets stronger. Not weaker, stronger, and at re-entry temperatures, where carbon fiber crumbles at 150 degrees, stainless steel holds its structure past 800. The material everyone dismissed as too heavy turned out to be the only material that works at both extremes. So while NASA spent 18 years and over $23 billion developing SLS using shuttle-era technology, SpaceX welded a rocket together in a field in Texas. From steel, and everyone kept laughing. They stopped laughing on the day it flew. Let's talk raw power. Because raw power is where this story goes from interesting to insane. Saturn V, the undisputed king for half a century, generated 7.6 million pounds of thrust. SLS, the rocket circled the moon a few days ago, produces 8.8 million. Respectable. An improvement. Starship, 16.7 million pounds of thrust. That's not an improvement, that's a different category. That's more than double Saturn V. 33 Raptor engines fire simultaneously on Super Heavy, the first stage booster. Each one burns liquid methane and liquid oxygen through a full-flow staged combustion cycle, the most efficient engine cycle ever mass-produced. And here's a number that should make you sit up. The latest Raptor 3 engine produces 280 metric tons of thrust, with a target north of 300. That's from an engine with fewer parts than a car engine. They simplified it so aggressively, it looks almost naked. If the F1 was a hand-built Swiss watch, beautiful, irreplaceable, each one unique, then Raptor 3 is a machine gun. Built fast, built cheap, built to fly again tomorrow. But thrust is just raw muscle. What Starship does with that muscle, that's where every other rocket in history gets embarrassed. Every rocket in history has had the same business model: build it, launch it, throw it away. Saturn V, $5 billion in today's money, gone, splashdown, done. SLS follows the exact same playbook, over $2 billion per launch. The RS-25 engines powering it, originally designed to be reusable on the space shuttle. Now they're single-use, built with reusable-grade precision, then deliberately sunk in the Atlantic. SpaceX looked at this model and decided it was insane, not impractical, not expensive, insane. So they built Mechazilla, a launch tower with two massive mechanical arms, chopsticks, designed to catch a 20-story rocket booster out of the sky. A booster taller than a building, weighing hundreds of tons. Descending on columns of fire, and two metal arms reach out and grab it. Like catching a baseball bat thrown from orbit. Every rocket in history has treated space access like a luxury. Starship treats it like a bus route. Current SLS cost per launch, over $2 billion. Current Falcon 9 cost per launch, around $67 million. SpaceX's target for Starship, $10 million. Maybe less. Put that in perspective. For the cost of one SLS mission, you could fly Starship 200 times. 200! That is freaking insane. And payload? Saturn V could carry 140 tons to low Earth orbit. SLS manages about 95. Starship, fully reusable, carries 150. In expendable mode, where you don't get the rocket back, 250 tons. The International Space Station weighs 420 tons. Starship could loft half of it in a single launch. Saturn V would have needed 3 launches for the same job. But here's the part that genuinely changes everything. Those numbers? They assume Starship launches once and goes straight to its destination. Starship has a trick that no rocket in history has ever pulled off, and it's a trick so audacious, most engineers said it was physically impossible. Orbital refueling. The idea is simple. The execution is borderline science fiction. A Starship launches, reaches orbit, and parks itself. Then another Starship, a tanker variant, launches, docks with the first one, and transfers its fuel. Cryogenic liquid methane and liquid oxygen pumped between two vehicles traveling at 28,000 kilometers per hour. Do that 10 to 12 times, and suddenly your ship isn't carrying 150 tons to low Earth orbit. It's carrying 150 tons to the Moon, to Mars, to anywhere. Saturn V carried astronauts to the Moon with a vehicle the size of a car and supplies for a few days. Starship could carry 100 people with supplies for months. The difference isn't incremental, it's generational. And remember, every single one of those tanker launches costs under $10 million if SpaceX hits their target. The entire refueling campaign, a dozen flights, could cost less than a single SLS mission. April 2023, IFT-1, the first full-stack launch. Multiple engines failed on ascent. The vehicle tumbled. SpaceX triggered the self-destruct. The most powerful rocket ever launched ended as a fireball over the Gulf of Mexico. SpaceX scrolled through the wreckage data, found the failures, fixed them, and rolled out the next one. And then IFT-5 caught the booster from the sky. From catastrophic explosion to catching a skyscraper with chopsticks in 18 months. Compare that to SLS, $23 billion, 18 years of development, one uncrewed test flight before strapping 4 humans to the top. Methodical, absolutely. But also a very different gamble. Let's be real for a moment. Comparing Starship to Saturn V isn't entirely fair, because Saturn V already did its job. It went to the Moon 6 times. It brought everyone home. It earned its legend. And SLS? SLS has carried the Artemis II crew around the far side of the Moon. 4 astronauts saw views no human has seen since 1972. That's real. SLS earned that flight. Starship hasn't carried a single human yet. It hasn't reached the moon. It hasn't even achieved full orbital flight with recovery of both stages in the same mission. But here's the difference that keeps every space agency on Earth watching. Saturn V was the end of the line, a masterpiece with no encore. SLS is a bridge, expensive, temporary, designed to carry the torch until something better arrives. Starship isn't trying to be the next chapter, it's trying to be the next book. Fully reusable, rapidly reflown, cheap enough to make space boring, and that, making space boring, might be the most revolutionary goal in the history of rocketry. Every rocket before Starship was designed to leave Earth. Starship was designed to leave Earth and come back. From the moon, from Mars, from anywhere. The plan for Mars isn't vague hand-waving, it's specific, alarmingly specific. First, send uncrewed starships loaded with solar panels, habitats, and fuel production equipment. That equipment uses Mars's own atmosphere, carbon dioxide, and subsurface ice to manufacture methane and oxygen. The same fuel Starship runs on, manufactured on Mars, from Martian air and Martian water. Then the crewed ships follow, 100 people per ship. Not in a capsule the size of a minivan, in a pressurized volume of over 1,000 cubic meters. And they don't leave one ship at a time. The vision is fleets, hundreds of starships, launching every 26 months when Earth and Mars align. Nobody has ever built a rocket with the stated purpose of making humanity a multiplanetary species. Saturn V went to the moon and then we stopped going. Starship is designed so that stopping is never the only option again. Few days ago, 4 astronauts looped around the moon aboard a rocket that costs $2 billion and will never fly again. And in a field in South Texas, a steel cylinder stands on a launch mount, ugly, dented, covered in heat shield tiles that sometimes fall off, waiting for its next flight. Its 11th, or its 12th. Because unlike everything that came before it, this one comes back. Saturn V proved we could reach the moon. SLS is proving we can go back. But Starship is asking a question that no rocket has ever dared to ask. Not can we get there, but can we stay? Fable signing out.